Alrighty, so we're dealing with question, free response question on chapter 3, quiz B. Okay, you're looking at it, chapter 3, quiz B. Similar question as quiz A. The only difference was different numbers, so you'll end up with a different formula. You can still try to do along with it to see if you get your answer. So first step is I kind of underlined it, the number that they give it to you and what are they asking for, and then you can kind of see that I asked the same question twice on here. So first thing first, I'm writing a formula. So I'll say C, I don't know, H, I don't know, what oxygens, maybe, right? So we said there is some carbon, some hydrogen, maybe possibly oxygen, plus again combustion reaction, always combusts with oxygen, go with CO2 plus H2O. Combustion analysis is really easy. Every time they give you carbon dioxide and water, go and find the mole and gram of the carbon and hydrogen. Okay, so that's what we're gonna get started. So I'm gonna say 32.35 gram. Actually, I should write down a little bit down here. That's okay. CO2. I'm gonna convert it all the way to gram of carbons. So I'm gonna say molar mass, 44.01 gram of CO2, 1 mole of CO2. For people who are wondering where I get this from, periodic table, molar mass. Okay, now we're gonna notice that 1 mole of CO2 is the same thing as 1 mole carbon because they only have one. And then we're gonna say arrows, leave a little space, and now I'm gonna go ahead and convert it to gram. So we're gonna say that is 12.01 gram. Notice that I just wrote it wrong because I'm gonna get mole, so mole should be on the bottom and then gram should be on the top. So let's do that again. 12.01 grams, 1 mole of C, right? So that we'll get the gram of C. Do the same thing with the water. So start out with 33.10 gram of H2O, 18 point, what is it? 16.016 gram of H2O, 1 mole of H2O. 1 mole of H2O equal 2 mole of H. So then based on that go away. You're gonna get with a mole of H. Now again, I want mass of H also. 1 mole of H, 1.008 gram of H. Again, if you don't know that number is on the periodic table, so you should be able to get that number. Okay. All right. So this is what you're getting. All right. So I'm gonna go ahead and divide this and multiply. So that is 0.735 mole of C, 8.828 gram of C. Leave it about 3 decimal places so that you don't over round things. 3.675. .704. Okay. Now go back and take a look at this question. This question a little bit strange because we give you organic compound, but we did not give you the mass of this, but we give you the mass of oxygen, right? So you're not gonna pretend that this other number is not there. So this is the answer for the mass of the organic compound, but let's say we didn't know this. How do I find it? Okay. Still remember conservation of matter, right? So matter or conserve, so that means on the left side of the reaction equal the right side of the equation. So the right side equation, we know that this is 32.35 gram. This is 33.10 gram. So what happened is I'm going to add these two. That should be equal to this side, what I don't know, plus the mass of oxygen that they give you, 29.40 gram. So if I add these and subtract with the 29.4, I should get the mass of hydrocarbon, which is I'm gonna quickly do this. $36.05, which is what I wrote up there. Okay, so 36.05 gram. This is my organic compound. So what I'm gonna do now is I'm gonna subtract it with the mass of carbon and mass of hydrogen to see if there's any oxygen there. Either you do minus minus here, or you can say minus parenthesis this plus this. Either way. Make sure you're entering them correctly. That is a gram of oxygen. Gotta find mole. 16 gram is 1 mole for the oxygen. Again, it's on the periodic table. We're gonna get 1.469, so 1.70, because 4698. So that's a mole. Now that we have all the mole, we can now do the ratios. So CHO. Now make sure you put it correct places. C is 0.735. That's the smallest one in this case. So that's why I'm dividing everything by C. 675. This is approximately 2 because I get 1.99999. This is 5. And this is 1. So based on this, my empirical formula is CH5O2. Now the next one is molecular formula. So to find a molecular formula, first you're going to find the molar mass of this. So this is answer to A. Okay. First find the molar mass of this, and then divide it to the molar mass of the sample. So if you look up, they give you molar mass of sample. So we're going to say 146.14, that's a molar mass, divided by this guy molar mass, which is 12.01 plus 1.008 times 5 plus 16 times 2. That should give you about 3. And then based on that, you're going to multiply this by 3. So my question for B is C3H15O6. That's my part B answer. Okay, now let's go to part C, write the combustion equation. Use this. So which is should be again easy to do. C. Okay, part C, C3H15O6. Right, and then we're gonna say plus O2 go to CO2 plus water. Okay, this part you might want to invest in eraser because you might have to erase your number. But let's just try them anyway. Okay, C, I'm gonna say 3 because it's 1, that's 3. H is gonna the one that get you trouble. There's 15, there's 2, that doesn't work. So I actually gonna double this. So that means now I can say H is 15 here, but remember my C is not 3 now, is 6. So I'm going to go back and change it to 6. Once you're done, you're going to check out for oxygen. That's a 15 plus 12. So you're having 12 plus 15. That is 27. Now take a look. 6 plus 2, 6 times 2, that's 12. I don't know this yet. So 12 plus something has to be equal to 27. So that means that something is 27 minus 12, right? So that's going to be 15. Okay. Yep. The thing with it is this is O2. So you can't say times 15 because if you times 15, you're going to get 30. So it's got to be 15 over 2 to make it 15. Guess what? We can't have a fraction. So what does that mean? Everything got multiplied by 2. So this now becomes 4 C3H15O6 plus 15O2 go to 12 CO2 plus 30 H2O. That's part C. Okay. Now part D and part E are sort of easy, but a little bit might be confusing. There's multiple ways to do it. Okay, so part D asks to calculate percentage of hydrogen in the organic compound. The organic compound being C3H15O6. You have one or two roads. One road is just based on the formula. We know that it has 15H, so I can say 1.008 times 15. That's a molar mass of 15 hydrogen, divided by molar mass of the whole thing, which, yes, you can go and find it, or you can go ahead and find the molar mass that they give it to you, which is 146.14 gram. That is the molar mass of the whole thing, C3H15O6. Okay, that will give you, let me see, 1.008 times 15 divided by 146.14. This much. Now notice that that's not percentage yet. To make it percent times 100, so go ahead and times it by 100. You're gonna get 10.35%, about 10%-ish. Now, let's say you don't want to do this route. You want to do another route. You will notice that earlier we do have the mass of hydrogen right here. And we do also know how much is the mass of the whole thing right here, because this is the mass of the whole thing. Because remember, this is this carbon dioxide and water minus oxygen, so this is the mass of the organic compound. So you can also do this divided by that. That also should give you the same approximate number. Right. Again, notice that you're not getting exact, you're getting approximate number in this guys. Okay. But it is close enough. Right. Let me say 3.704 divided by 36.05 times 100. We're gonna get 10.27%. Approximately speaking, we're dealing with about 10% of the mass of the organic compound is hydrogen. Okay, now let's look at E. E said how many molecules of carbon dioxide are in there. All right, so you can either start from gram of carbon dioxide or mole of carbon dioxide will do. Now, something to notice, you can use the gram of carbon dioxide, so you can say 32.35 GCO2. I don't want gram go on the bottom. By the way, that's 44.01 CO2, 1 mole CO2. Now notice it's asking for molecule. So 1 mole of anything has 6.022 times 10 to the 23rd molecule. Now notice that it's not asking for oxygen. If it's asking for oxygen atom, that would be this times 2, because each carbon dioxide has two oxygen atoms and 1 carbon atom. So that will be different part. Okay, so that's what you get. You solve this, you're gonna get internal of 10 to the power 23rd. So yeah. Okay, so this is 4.4265 times 10 to the 23rd molecules of CO2. Now you could also start from this guy right here. I don't know if you guys noticed. We did find out the mole of carbon, which is the same thing as mole of carbon dioxide. So I could go ahead and do this to bypass this 2 part here to start from here. So I could say 0.735 mole of CO2 is gonna to be 1 mole of CO2 for 6.022 times 10 to the 23rd molecules of CO2. Okay, either cases you'll get the same answer. This is my answer. Right, you can also do this also. I'm not gonna go ahead and calculate it. You should see that it is got very, very close to the answer. All right.